Module 1 for Computer Organization and Architecture, and this Module 1 consists of several sections. First one, basic structure of computers, that include functional units, basic operational concepts, bus structures, memory locations and addresses, memory operations, instructions and instruction sequencing, addressing modes, ARM example, basic input-output operation, and stack subroutine calls. Then first section, basic structure of computers, and this consists of digital computer, personal desktop computers and supercomputers. Then digital computer. Digital computer is a fast electronic calculating machine, and it accepts digitized information and process list of internally stored instruction and produces output information through list of instruction known as computer program. This digital computer uses its internal storage as the computer memory. Then personal and desktop computers. The most common type of computers we are using in homes, office, business, etc. belongs to personal or desktop computers. Netbook is an example for personal computer. Laptops, tablets, etc. all belongs to personal or desktop computers. Supercomputers. Supercomputers are mainly used for large-scale numerical calculations, example weather forecasting, aircraft designing, etc. That's our for basic structure of computers, and then next one, functional units and basic operational concepts and bus structures. The functional unit consists of input, output, memory and processor. The memory, we know that it stores programs and data and consists of primary storage and secondary storage. Then processor, that consists of an arithmetic and logic unit and control unit. This functional unit can be divided into 5 parts: input, output, ALU, memory and control unit. Input is the input we are giving through the computer devices and keyboards, and output will be the final result we are obtaining. Then input accept information from devices such as keyboard or from other computers. And the memory we know that it stores programs and data and consists of two types of memory, primary memory and secondary memory. Then the types of memory in primary section, that is random access memory, which can be read and changed in any order, typically used to store working data and machine code. ROM, read-only memory, it is a non-volatile memory used in computers and other electronic devices. Third one, cache memory. Cache memory, also called CPU memory, it is a random access memory that a computer microprocessor can access more quickly than it can access a regular RAM. That is, it belongs to the family of random access memory, RAM. Then secondary storage. Secondary storage is used when large amount of data and many programs to be stored. For example, optical disc, magnetic tapes, hard disk, etc. belongs to secondary storage category. Then some merits for primary storage memory and secondary storage memory. In primary storage, it is fast, and here the programs are stored in memory while they are executed, and large number of semiconductor storage cells are there in primary storage. Then secondary storage is larger and cheaper than primary storage. Then output send processor the result to outside world. Suppose we give instruction to print something to the computer device, and the output will be the printed page we get from the printer. This is what input and output means. Then control unit. Control unit is a nerve center of computer, and it sends control signals to other units, and all computer operations are controlled by the control unit, and timing signals are also generated by control unit. What is timing signal? The signal that determines when given action is taken place. This is known as timing signal. Then arithmetic and logic unit. In computer, most computer operations are executed in ALU of the processor. It loads operands into the memory and bring them to the processor and perform operations in arithmetic logic unit and store the result back to memory. These are the various functions performed in the processor of arithmetic and logic unit. Then control unit, as we said, all the computer operations are controlled by control unit, and here the timing signals are also generated by control unit. One basic diagram for functional units. Here you can see input output, then processor, and in between that there will be the memory. The processor consists of arithmetic and logic unit and control unit, and input output consists of input device and output device. This is a functional unit for computer structure. This functional units is divided entirely into two sections, that is combinational elements and state elements. Then what is combinational elements? Elements that operate on data values is known as combinational elements, and elements that contain state is known as state elements. Then basic operational concepts. The basic operational concepts consist of various steps known as typical operating steps. First one, programs reside in memory through input-output devices, and PC is said to point to the first instruction, and contents of PC is transferred to memory address register, and after that read signal is sent to the memory, and first instruction is read out and loaded to memory data register, and contents of memory data register are transferred to instruction register, and then decode and execute the instruction and get operands for arithmetic logic unit from general purpose register and memory and perform operation in arithmetic logic unit, then store the result back to general purpose register and memory, and during the execution process program counter is incremented to next instruction. അതായത് ഫസ്റ്റ് പ്രോഗ്രാംസ് എല്ലാം തന്നെ മെമ്മറിക്ക് ആഡ് ചെയ്യുന്നത് ഇൻപുട്ട് ഔട്ട്പുട്ട് ഡിവൈസസിൽ കൂടെയാണ്. അത് കഴിഞ്ഞ് കഴിഞ്ഞാൽ പ്രോഗ്രാം കൗണ്ടർ ഫസ്റ്റ് ഇൻസ്ട്രക്ഷനിലേക്ക് പോയിന്റ് ചെയ്ത് സെറ്റ് ചെയ്ത് വെക്കും. ദെൻ കണ്ടൻസ് ഓഫ് പി സി ഈസ് ട്രാൻസ്ഫർ ടു മെമ്മറി അഡ്രസ് രജിസ്റ്റർ. ഈ പ്രോഗ്രാം കൗണ്ടറിലുള്ള എല്ലാ കണ്ടൻസും മെമ്മറി അഡ്രസ് രജിസ്റ്ററിലേക്ക് ട്രാൻസ്ഫർ ചെയ്യും. ദെൻ മെമ്മറിയിലേക്ക് ഒരു റീഡ് സിഗ്നൽ സെൻഡ് ചെയ്യും, ഈ കണ്ടൻസ് എല്ലാം തന്നെ റീഡ് ചെയ്യാൻ വേണ്ടിയിട്ട്. ഈ സിഗ്നൽ സെൻഡ് ചെയ്ത് കഴിഞ്ഞാൽ ഫസ്റ്റ് ഇൻസ്ട്രക്ഷൻ മെമ്മറി ഡാറ്റ രജിസ്റ്ററിലേക്ക് ലോഡ് ചെയ്യും. ഈ മെമ്മറി ഡാറ്റ രജിസ്റ്ററിലെ കണ്ടൻസ് എല്ലാം തന്നെ ഇൻസ്ട്രക്ഷൻ രജിസ്റ്ററിലേക്ക് ലോഡ് ചെയ്യും. എന്നിട്ട് എല്ലാ ഇൻസ്ട്രക്ഷൻസും ഡീകോഡ് ചെയ്യും, എക്സിക്യൂട്ട് ചെയ്യും. അത് കഴിഞ്ഞിട്ട് ALUവിന് ഓപ്പറൻസ് ഗെറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് ജനറൽ പർപ്പസ് രജിസ്റ്ററിലേക്കും മെമ്മറിയിലേക്കും ഓരോ സിഗ്നൽ സെൻഡ് ചെയ്യും. അത് കഴിഞ്ഞ് എല്ലാ ALUവിലുള്ള എല്ലാ ഓപ്പറേഷൻസും പെർഫോം ചെയ്ത് കഴിഞ്ഞിട്ട് അതിൻ്റെ റിസൾട്ട് ജനറൽ പർപ്പസ് രജിസ്റ്ററിലേക്കും മെമ്മറിയിലേക്കും സെൻഡ് ബാക്ക് ചെയ്യും. ദെൻ എല്ലാ എക്സിക്യൂഷൻ കഴിയുമ്പോഴും അല്ലെങ്കിൽ എക്സിക്യൂഷൻ നടക്കുമ്പോഴും പ്രോഗ്രാം കൗണ്ടർ ഇൻക്രിമെൻറ്റ് ചെയ്തുകൊണ്ടിരിക്കും നെക്സ്റ്റ് ഇൻസ്ട്രക്ഷനിലേക്ക് വേണ്ടിയിട്ട്. ഇതാണ് ബേസിക് ഓപ്പറേഷണൽ കൺസെപ്റ്റ്സ്. Then bus structures. Bus structure, a group of lines that serves as a connecting path for several devices, is called a bus, and there are two types, single bus and two bus. Here the architecture or a simple diagram for single bus and two bus structures. This is the single bus structure that consists of input, output, memory and processor that are all connected through a single line. And here the two bus structure, here the input output units, processor and memory are all connected in a two-way using different registers known as memory address register, databases, etc. Then single bus. Single bus is an easy way to interconnect functional unit, and here single bus can be used only for one transfer at a time, and one merit for single bus is low cost and flexibility over the peripheral devices. Then two bus, system that contain multiple buses achieve more concurrency and it allow two or more transfers. Merit is better performance and demerit is increased cost. So one difference between single bus and two bus is single bus allow only one transfer at a time and two bus allow two or more transfers. In single bus structure, inside the CPU, different components are linked by a single bus or single line. In single bus structure, CPU uses instruction register, instruction decoder, program counter, memory address register, memory data register and general purpose register. Whereas in two bus structure, various units are connected through two independent bus, and here input output units are connected to processor through an input output bus, and memory is connected to the processor through memory bus. And this input output bus consists of address, data and control bus, and the memory consists of address, data and control bus, which means it requires different registers or different lines for input output and memory bus. Then memory locations and addresses. Numbers, characters and instructions are stored in computer memory. We know that in memory all the informations are stored in the form of numbers and characters, and millions of storage cells. Memory can store single bit of information having the value 0 and 1. Memory consists of millions of storage cells, and all the informations are stored in these cells in the form of 0 and 1 values. And the memory is organized in such a way that group of n bits can be stored and retrieved in single operations, and where n is the word length. And modern computers have a word length from 16 to 64 bits, and if the word length is 32, then a single word can store 32 bits. This is memory locations and the addresses. Then instruction sequencing. Instruction sequencing, the program stored in memory consists of an instruction, and the program execution is a series of instruction cycle. Then instruction cycle consists of two phases, that is instruction fetch phase and instruction execute phase. The instruction is fetched from memory location whose address is pointed by PC to CPU register, and then it is decoded. This is known as instruction fetch phase. And instruction in instruction register is examined to determine which operation is performed. This is what happens in instruction execute phase. Then specified output is then performed by processor. These are the steps in instruction sequencing. And what is the definition for instruction sequencing? Instruction sequencing is also known as straight line sequencing. During program execution, instructions are executed one after another until a branch instruction is encountered. This is known as instruction sequencing or straight line sequencing. Consider an example. Then add two numbers. Consider this program C equal to A plus B. Then assume computer allows one memory operand per instruction, and then assume the word length is 32 bits and the memory is byte addressable. Then processor contain a register called program counter. Begin executing the program. Address of first instruction must be placed into the program counter. That is, while doing the program or started executing the program, the first instruction you must place in the PC. Then CPU control your circuits use information in the PC to fetch and execute instructions one at a time. Then the CPU control units use the information that is stored in the program counter to fetch and execute instructions during the program execution. And this is called straight line sequencing. One example for this execution, that is during execution of each instruction, the PC is incremented to next instruction. That is, here this will be PC is set to I, and in the next instruction it is incremented to I plus 4, and in the next it is I plus 8. And after instruction at I plus 8 it is executed and PC contains the value I plus 12. After I plus 8 is executed, the next will be I plus 12, that is, the program counter is incremented to I plus 12. And this is the address of first instruction of the next program, and this is taken as address for the next program after executing the first instruction. So these are all for the part 1 notes for module 1 computer organization and architecture. The topic covered in part 1 include the basic structure of computers, that includes digital computer, personal computer and supercomputers. Then the various functional units, input, output, ALU, memory and control unit, and the primary storage and secondary storage, the bus structure, single bus, two bus, and the memory location and addresses. Then instruction sequencing, what is instruction sequencing and straight line sequencing, example for instruction sequencing, etc. And the next part will be addressing modes, and that will be updated soon.